We've got 13-3. Geometric probability. So we've been looking at some different kind of probability scenarios based on, marbles and sports teams and stuff. This section here involves geometric measures such as length or area. Geometric measures such as length or area. So let's look at an example of what we're talking about here. So if I have a line segment, and it is line segment A, B, C, D, and I'm looking at BC here, I want to find the probability of choosing a point on BC, just on that segment out of this whole AD here. So this is how we do this. We say the length of taken ignore my dryer over there. Length of taken over total length. So I just take the length or the taken or the target and then over the total length. So I'm just going to take BC and put it over AD. And that would be my answer. So let's do an example with some numbers here. So I've got J, K, and then farther over here is going to be L, and then M. The distance between J and K is 3, between K and L is 7, and between L and M is 4. So those are the distances between those points. Now we're going to be asked to find the probability that X, that's just a point anywhere that we just put an X somewhere on this line segment. The X will be on KL. So we put a point X somewhere on this, and let's find the probability that it'll end up on KL. That's that middle segment. So all I do is I take the total, and that is 7 plus 3 plus 4, which is 14. I put that in the denominator. Remember, the total length goes into the denominator. The length taken, or the target area, so whatever you want to call it, is what we put on the top. So KL is the target or the taken area, so that's 7. And 7 over 14, let's reduce that down to 1/2. Oops. So we divide the top and the bottom both by 7, we get 1/2. Alright, so this would be a U-try. We're going to use this same line segment here, and we're going to find the probability that X will be on LM. So we've got LM. Go ahead and pause and do this U-try, and we'll come back. Alright, so hopefully what you did was you took LM, which is 4, and you put it over the total, which is 14, and then you reduce that. The common factors of each of these between these two is 2. So 4 divided by 2 is 2. 14 divided by 2 is 7. So 2/7, or 2 out of 7 chance is your probability that X will land on LM on this line segment. Alright, so that's line segments. So let's now look at area. Probability with area. So with area here, we're going to have the target, or the taken, over the total. So just like with the segments, but this time we're dealing with area. So let's see if we can do some examples. So this first example, we're going to have this guy over here. And he is parachuting. And he's parachuting down onto this target on the ground. We've got 3 circles here, a smaller one, medium, and a large one. Now, this one, this target, oh, this smaller one should be a little bit bigger, but it'll be okay, not to scale. Okay, from here to here is 1. The radius of the smaller circle is 1. From here to here is 1. And from here to here is also 1. Alright, now I'm going to shade in this little donut right here, and you'll see why in just a second. Alright, let's see if we can let's see what we have to do here. So remember, the area of a circle is pi r squared, where r is the radius. So here's our example, what we're going to find out here. We're going to find the probability that this guy lands on the middle, or the center circle. So that little guy inside there, we're trying to find the probability that he's going to land there. Okay, so we need the total, and so that'll be on the bottom. And we need the inside here, and that'll be on the top. So the area is pi r squared. The radius of this little guy is 1. So pi 1 squared. That's the target that we're trying to hit. Now, let's say for the total area here, we've got 1, 2, 3. So the radius for the the whole thing is 3. So we say pi r, which is 3 squared. The pi's, pi divided by pi is 1, so we can ignore pi altogether, it goes away. And so 1 squared is 1, 3 squared is 9, 1/9 chance that he's going to land right there on that center circle. So that's the first one. Let's look at one more, maybe 2. So now we're going to find the probability that he lands in the middle ring, the part that I shaded in there. Middle ring. Now this one is a little tricky. So in order to get the target, I've got to take this big circle, or the middle size circle, right? I need to subtract this part out of it because that's not part of the middle ring. I have to take the center out of it. I have to cut out the hole for this donut. Alright, so let me show you what that looks like. So the radius of this center of this medium-sized circle is 1, 2. Alright, so pi times 2, oops, pi r squared is our area, and 2 is the radius, so pi radius squared. I need to subtract the whole of the circle, which is pi times 1 squared. I keep saying that. Pi 1 squared. And then the total, again, is the same as the total as we had before, pi times 3 squared. Okay, now let's look at this here. Now, both of these terms have pi in it, and there's pi down here, so I can factor all of these pi's out. And then I end up with 4 minus 1 over 9 3/9, which is 1/3. So this guy has a 1/3 chance of landing in that the little donut inside there, that middle circle. Next, let's you guys try this one. So I want the probability of landing in the outer ring. So just the outer ring, not the inside one, not the little one, just the outer one. Okay, so you're going to need to subtract out the area of this stuff in here so that you can have this clean ring out here by itself. Okay, go ahead and see what you can do. Go ahead and pause. Alright, let's see how you did. So I'm going to take the probability that this guy is going to land in the outer ring. And the way I'm going to do that is I'm going to take the whole area, which is pi times the radius, which is 3 squared,